In this video, we're going to find all the missing sides and angles of this rectangle back here. And when you're finding the sides and angles of any shape, you would always want to remember what shape you're working with, as sometimes the shape itself has some properties that you can use when it comes to finding those missing parts. For example, since this is a rectangle, right away, without looking at what they give me, I can go ahead and fill in that every angle is 90 degrees. All right, that's one of the biggest properties about rectangles. I also know that the diagonals are all going to be congruent, as well as, since this is a rectangle, it's also a parallelogram. The opposite sides are not only parallel, but they're also congruent as well. So I can put a couple tick marks here, maybe 3 tick marks here and here. All right, and then that way when I find one, I know that the other one was going to be the same thing as well. So let's see what they give us. They gave us that JKH, this angle, let's see, JKH, that's this angle here, is going to be 32 degrees. I'll use my angles. I'll go with pink for this one. Yeah, it's fine. I guess I did those ones in black, but that's okay. So I'll say this is 32 degrees. And this actually unlocks a ton of information, because not only is this angle 32 degrees, but this is an isosceles triangle. And we know that the base angles in isosceles triangles are the same. So this is also 32 degrees. As well as this is an alternate interior angle, since this is a parallelogram as well as a rectangle, up here at 32 degrees. And again, another isosceles triangle, or you could think alternate interior angle from this one, but this is going to be 32 as well. Okay, what else does that do? Well, because this is 90 degrees, 90 minus 32 is going to be 58. So the other side is 58. And because all of my diagonals are the same, this is another isosceles triangle. This is 58 degrees. All right, and likewise, let's be the same math over here. 58 and 58, just like that. Okay, and additionally, think this is 32 and this is 32. Well, this top triangle right here, if I take kind of this top part, that kind of envelope looking thing, that's going to be 64 if I add those two together. And if I think that there's 180 total degrees in any triangle, then 180 minus that 64 is going to be 116 degrees for this angle. All right, this is a vertical angle with this one, so that's 116 degrees as well. And then the opposite math, well, this is going to be 64 for those two, right? Kind of think alternate, or was that remote interior angle theorem for those two. So this is going to be 64 and 64. So those two should add to be 180, and all three of these should add it to be 180. So I think just by knowing one angle in a rectangle, you actually can figure out every single angle, which is kind of cool. The other part that it gives me is that FG, let's see, where is that? FG, that's the top here. That is 8. So let's mark up our sides in red. So that is 8. And because this has 2 tick marks, so does this. That's going to be 8 as well. And so there's only a few things that I don't know yet. I don't know what the length of my diagonals are, as well as I don't know the other 2 sides. And so I think we're going to have to use some trig, which means you might need to have a calculator handy to use sine, cosine, or tangent. And I'm going to look at kind of this bottom triangle right here. In fact, I might make a difference. I might put that off to the side so there's not as much stuff going on in this one. And if I think of this right triangle, so again, I'm taking kind of this bottom part here. If I make it look similar, I know that this is 8. This is my 90 degrees, and then I'll use the 32. How about that one? I'll use this 32 degrees. And in this, if I want to find, let's say I want to find this outside part first, right? Those two kind of correlate. If I call this x, compared to my 32 degrees, I have the opposite and the adjacent. That's going to use tangent. Remember our word so, ka, toa in our trig section? That's the toa, the opposite and adjacent, okay? And so if I say tangent of 32 is going to be the opposite x over the adjacent 8, then I can multiply both sides by 8 and get 8 times tangent of 32. That's going to cancel and give me x. So in the calculator, let's type that in. Let's go 8 tangent of 32. And it says this is 4.9989. Okay, I think it's pretty safe to call that 5. So we're going to say 5 equals x. And therefore, if this is 5, then so is the opposite side. All right, now you have some options when it comes to finding this diagonal here. Again, that's going to be like, if I were to say this is y, and this is now 5, I could say a squared plus b squared equals to c squared, use the Pythagorean theorem, or because we're using trig here, I might as well use it again. And I'm not going to use the 5 because it is slightly rounded, right? You probably could, but I'm going to use the 8 since that's what it gave me. And if I do, compared to my 32, I have the adjacent and the hypotenuse. So this is going to use cosine, that's the ca and SOHCAHTOA, cosine of 32, and that should equal the adjacent 8 over the hypotenuse y. Make my 8 a little better. Got to multiply both sides by y, and then I get y times cosine of 32 equals, those cancel, so it just equals 8. Then to get the y by itself, I'm going to divide by cosine of 32. On both sides, divide by cosine of 32. So it cancels on this side, leave me with just y, which is good. And then 8 divided by cosine of 32 is 9.43. So if we round a little bit, we'll just call it 9.4 for the y here, 9.4. And what is that y again? That is all this side. So in that triangle, this is like my k, the f up there, and then down there is the h. And so this 9.4, it's actually going to be probably split between both of these parts. So instead of 9.4, I'm going to take and divide that by 2. 9.4 divided by 2 is 4.7. So I'm going to call each part of my diagonal 4.7. 4.7. And because this is a rectangle, those are also going to be 4.7s. Right, like there. And now I think I have all 4 sides, all 4 parts of the diagonals, my inner angles, and then the angles on each corner there. And so therefore, I think we have solved this rectangle. All right, hopefully this video helped you out in solving all the sides and angles that are missing in this rectangle. Until next time, keep doing your math homework fast and accurately.